Hello everyone. So in this video, we'll talk about network address translation. We call it as a NAT. It's a very important concept in networking. So let's understand its origin and how it is going to be used. So we know that the entire address space for the IPv4 uh, version is 2 power 32. That means these many possible addresses are there in IP version 4, which is defined on 32 bits IP address. So initially, it appears that this uh, address space is quite big, and the idea of the IP is to assign every machine one unique identity so that when the communication is done, every node can be identified. So when the IP address is assigned, we are assigning it from this address space, but then it is realized that this is appears to be too big, but the speed at which we are going to that the massive usage of network has been come into existence, this amount of addresses appears to be not sufficient. So we worry about the depletion of these IP addresses. So then we have decided to address this kind of issues. Now, uh, let us understand some of the issues, and then we see how can it be addressed by the net. So the first issue is that uh, we cannot assign every individual uh, host machine a unique IP address. This is something to be addressed. Other thing is, let's say one organization has assigned a block of address. Let's say the organization has assigned 20 addresses. For example, let us take one example 192.168.1.2, and we are going to assign 20 addresses to this organization, let's say. So it has given the range 192.168.1.21. So these are the 20 addresses we have assigned. Now, one thing to understand that whenever we assign a block of addresses, these addresses are assigned in a contiguous way. We have talked about subnetting of the network, and whenever we do subnetting, the subnetting is also to be done in a contiguous way. Means we assigning all the addresses in continuity. So let's say this is one organization who has assigned this address, this block of address, and then just after this address, we have assigned the other block to another company, and then to third organization, let's say. And after some time, the same organization needs more addresses, then we cannot able to assign the address immediately after this range, because already that set of addresses has been assigned to any other organization. So in that case, we have to assign some other set of address to this same organization, and this will create a issue, because in that case we cannot do very efficient subnetting. Subnetting for a larger block need to be done from a single larger block, which all the IPs are in the same range. So if you have the range from 2 to 21, 192, 168, something like this, and other block is, let's say, 200, 1.2.3, and then it goes up to some range, then you cannot take this entire range of IPs as a one block. This is also one of the issue. To address this kind of issue, it has been decided to uh, divide the entire set of addresses into two parts. We call it calling as a private and public addresses. Now, private addresses are the addresses which are having a local identity, and public IPs are something which have a global identity. What does it mean? It means if we have this block and we have this block. So if I have one host machine we are having, and let's say this host machine is assigned one address, uh, 192.168.7.9. Now the same address cannot be assigned to any other host on the same network. So this is unique in its local domain, but the same IP address can be assigned to any other host in the other network, because this is something unique, but only it is inside this in this block, or in this network, you can say. So this can be repeated, this can be duplicated without creating any problem. Now, We already discussed that we have certain blocks are special. We are calling the private block. And so we have like 192, 168, 7.9. We have 10 dot series is also there. So we have a block of addresses which are kept as a private address. And this can be used by multiple organization and it does not affect the actual communication because they are private in their domain only. So this is private IP addresses. Now, the communication inside the network is to be done, then private IP is okay. It is unique, but it is not visible to the outside world. It has not uh, unique in a global context. Now, if any of the hosts want to communicate outside, it must have an identity, must have an IP address, but that IP address must be unique in the global context. So then we have something called public IP. So let's say we have uh, one IP, which we are calling as a public IP. Let's say this is uh, 201.1.2.3. Now, this is a public IP, which means it's a unique uh, identification and can be visible externally. So, we have private IP, we have public IP. So, how the communication is to be handled? So, if any of the host machine, let's say this is a host having this private IP, wants to communicate outside this network or want to connect to the external world. So, in that case, it will send a request to the gateway, that is a kind of router, you can say. The router is acting as a gateway that allows all the packet to enter and goes outside from this gateway. So when this host wants to connect to the outside, it will send a request that I want to connect to a particular destination. So the moment it leaves from this gateway, this private IP need to be replaced with this public IP. Means to the outside world, this host is only identified by this global IP. So it goes and communicate to the destination, and if something is replied from the destination, the reply comes back only to this IP. And when it goes to this router, the router will again will check, okay, this IP need to be replaced with this, and connection to be established to this host machine. So what we have seen here that in order to make a communication to the outside world, we are using the private IP and we are using a public IP. And also we need some mapping is there. We need to map from private to public and public to private. And this is the job of the NAT. So the NAT address translation, this NAT manager, which is basically configured inside the router, it is basically handling this job, mapping the private to public and public to private. So now we'll see in more details that how actually this concept is applied in our day-to-day communication. Now let's see the scenario. This is one network which are having these number of host machines are there. They are having this. This is a they are using a private IP. So I think you have already gone through the blocks which are assigned as a private IP. So this is a private block. So all the IPs you can see, these are all private IPs. So these are the IPs assigned to this host machine. Now, this host wants to connect to some any other host or to any server outside this network. So what is going to happen? It has to send a request that goes through this router, and router will now they have means this organization has taken one public IP for a global communication. So whenever the request has to be delivered outside the network, the local IP, the private IP need to be replaced with the public IP and then request is to be sent. This is how the things are working. So now let's have a look at how the table is to be managed, how this net router will take care of everything. So this is the representation. This is the same scenario. This is network. So it send the request. The request goes to this net router. The router will replace this IP with the global IP, and the packet is delivered somewhere in the internet. And then when the reply comes back, so to the outside world, this IP is not visible. Only this IP is visible, which is a global IP, which is a public IP. So the request, this is a kind of sender. And then when the request comes, so the request will also come to the same IP. And then when this packet comes to this router, the router will be able to easily identify that this address is basically reflects to this host IP, and then it will deliver the packet to this host, not to any other host. So now let's see that what are the entries to be made for this kind of communication. So here, see here, this is like more clear scenario has given here. So this is the source which is having a private IP. This is a destination which is a global IP, public IP you can say. Okay. Now this source want to connect to globally. Now this IP is not a part of the network, which is something outside the network. So now you can see here the steps are given: step one, step two, step three, and step four. So when this is to be done, it will first go and make an entry that I am the private IP and I want to connect to this global IP. And then this packet is delivered. After making the entry, the packet goes here. The router will change this private IP to global IP. You can see this is the public IP which the organization has purchased. So in order to make a global communication, the organization need to have one public IP mandatory. So at least one IP must be there. So let's say this public IP is to be used for a global communication. So this IP has been replaced with this global IP, and then packet is delivered to the destination. Now, after the processing at the destination, let's say destination replies with some so let's say maybe acknowledgement, or it may send something back to the sender. So this packet is coming. So you can see the sender. The sender is the destination, and the receiver is this IP which is we have used here. Now, when this packet is reaching here, it will look to the source part, that who is the source. The source is 25.8.2.10, and in the table, it is mapping to this IP. So it can easily be identified that the packet need to be delivered to this 172.18.3.1, which is the same one. So this is how the things can be resolved. So it appears to be straightforward, but there are many scenarios and we will come across where we can see that there is a collision may occur. Means this table cannot be uniquely identified. The entries, there may be a clash. So let's look to the scenarios. So this is what we have seen so far. This is a kind of private IP, and it wants, this is a sender having a private IP. It wants to connect to any destination, to any outside the network. So it will make an entry here that P1 wants to connect to D1. When it goes, it will replace this private IP with the global IP, and then it goes to the D1. So D1 is maybe some destination here. When the reply comes from D1 to G1, so this is to be mapped in the table, and D1 map with the P1, and the table packet is forwarded to P1. This is how the things are happening. Now, so we have just seen that only one host wants to communicate to the outside world. Now, what about if many, let's say there's a network of 100 host machines are there, 100 host nodes are there, and if they want to communicate, so let's say we take the two example. So we have two private IPs, P1 and P2 are represented the host. They are having some private IPs. Now, P1 wants to connect to D1 to some of the destination, and it connects to D2. So before actually that packet is delivered, it will make an entry. P1 wants to go to D1, P2 wants to go to D2. But before the packet leaves this network, the router will change this P1 to G1 to the global IP, and also P2 to G1, the global IP. And the packet is delivered. And when the response comes, you can see here D1 to G1 and D2 to G1. So by looking from D1, we can find out that this response is for P1 and this response is for P2, and the things can be very effectively handled without any collision, without any clash. Now look at this. Now we'll see that there are some issues. It's not that much straightforward. Now see, this is one private host having a private IPv1, other host having private IPv2, and both want to connect to a same external host. Host want to connect to the yahoo.com or any website inha.uz, which runs on a given public IP at the same port, right? So here two different users are here, but want to connect to the same server with the same destination ID. So as a rule, it goes to the this NAT table. NAT table make an entry. P1 wants to go to D1. P2 also want to go to D1. And when it leaves the packet, this P1 replaced with G1, and P2 also replaced with G1, and it is delivered. Now the problem is now going to appear. When the reply comes back, we are coming. from D1 to G1 and D1 to G1, and in the NAT table, it is difficult to uh, differentiate that which packet is to be sent to which of the host, and this creates a problem. So whatever the strategy we have seen so far is not going to work. So what is the solution for it? So the solution for it is that instead of using one public IP, if we have used two public IP, then the solution, then it can be managed. Now look at this. So now instead of having one public IP, now the organization is having two public IPs are there. So it will work like this. So P1 wants to connect to D1, okay, and P2 also wants to connect to D1. So now it will connect the table for each public IP. So earlier we have only one table because we have only one public IP. Now we have two public IPs, so we have two table need to be maintained. So when this P1 wants to communicate to D1, it will make an entry. P1 wants to connect to D1, and the packet is delivered that P1 will be replaced with this global IP and packet is delivered here. Now, after some time, let's say P2 wants to D1. So again, it will first refer to the table and will check that already D1, the same destination has already have an entry here. So we cannot use this table, but we will look for the other table. That means this IP has already been engaged and cannot be used for the communication because in this case, both the destination is same. So we'll make the use of the second table, use a other public IP, and the entry is P2 wants to connect to D1, and this P2 is now replaced with G2. Now you can easily see here that when the reply come back, it comes with uh, this is G1. That means this is when the reply is coming from here. It says from D1 to G1, and that means you have to look in the G1 table. And when this says D1 to G2, you have to look for a G2 table, and you can easily find that there is no collision happening. So we have resolved this problem up to some extent. But the issue here is uh, if we have two global IPs, then we can make sure that two host machine can connect to the same destination. So if we have four IPs, 10 IPs, so then up to that limit, we can make sure that can make a very smooth connection. But this is not a very straightforward issue because we are limited with the number of uh, IPs which are available. So if the five IPs are there, five public IPs are there, that means only five hosts can connect to the same destination. We are limited with the number of public IP. So this idea is going to help up to some extent, but this is not very much meaningful, and we are bound with the number of public IPs and number of hosts that connects to the same destination. If there are 100 and hosts in the same network and they want to connect to the same destination, then this is going to not work. Then we need to have that many number of different public IPs, which is again very costly to the organization. We want some better approach to handle this in this kind of situation. So let's see. So better solution is we can make use of socket. Socket is a combination of port plus IP. Now this idea will resolve all the issues that we have seen because the combination of IP and port will always be unique. First, let us understand the scenario and then we'll see how it is to be managed. There is uh, one host machine, okay, and there is one, let's say, one server running. In this case, we have taken Yahoo, let's say yahoo.com, okay. So it has some IP address, which is a public IP, and also runs on port number 80. Now, let's say the same machine. So we can open two browsers. Let's say the first browser and second browser we have opened, and through both the browsers we want to connect to the same yahoo.com. Okay. So in this case, we are sending two requests, but both the requests will have the same IP number, means the IP address because both are running on the same host machine. So the IP will remain the same. So if we try to do this kind of thing, then resolving the two connection with the same IP will be going to be difficult. So we will be using the combination with the port, because every request, when it is every connection, every application which is going to be connect to this port, to this yahoo.com, will be assigned one port. So when you use this browser and want to connect with Yahoo, then you are going to be assigned one port number here. Let's say this is a 24, just for example. And here we have also assigned some number. Now this is very sure that when it is 24 assigned here, then the OS will not give the 24 here, because the OS will take a note that what port numbers are already been assigned, and it can assign any other dynamic port number which is not 24, let's say 25. Okay. So now if you look to this, the combination of IP and port number will differentiate this connection. So even in the same host machine, if two different requests are sent to the same destination, we can easily distinguish with the combination of the port number, and that makes a socket. Now let's see how it is going to be taken care uh, in the network, kind of a net table. Understand this. This is three hosts having the IP, and this host wants to connect to the, and it's given here the IP is this, and it is assigned this port number, and it wants to connect to Yahoo, and the Yahoo IP is this, it runs on this port number 80. So what we are doing here, so the very first step is we must be assigned one port number to it, and then we make a table entry. So step number 2 is making a table entry. Here you can see the sender, means the sender private IP, and is the port number. We have make a rule that all the entries, all the private IP and port number is now replaced with this public IP and port number. Now the organization is having using this public IP and this port number for setting a global connection or the external connection. So when the request is to be sent, this IP is replaced with this public IP, and this port number has replaced with this port number. So you can see step number 3, this has been replaced, means the actual IP and port number is now replaced with this global IP and port number, and it is now sent to this destination, which is a yahoo.com. Okay, next. So now you can see once the request has been sent, and now the reply has coming from the Yahoo. So it's come from the Yahoo, which is this is the, so sender is the Yahoo. Now the source is the source address is this Yahoo address, and the port number and destination is 145 here. So now after receiving this packet, now it will look to this destination, which is 145.12.13.7. You can look at here, and you can easily differentiate that, you can easily find out, means the net table can easily find out that this entry correspond to this particular host machine, and then this message has been forwarded to here. So this is very straightforward, because here only we have one entry. Now we have to take a case when multiple entries are there, and how this technique will resolve any clash. So let us take another example. So now you can see here, let's say there are two different host machines having this private IP and running on this port number has been, we now want to connect to this yahoo.com having this IP address and running on this port number. Okay, so now you can see here, uh, the main thing or main emphasis here is, if you look to the combination of the public IP and the port number assigned to the application, the sender port number, this combination is always different, and this will eliminate any clash, and we can easily map that which entries, which reply to be sent to which of the host machine. And though there is no chance that you will be assigned the same port number for two different application, but let us assume that at one, uh, let's say there are two host machine, host 1 and host 2, and this is the IP for host 1 and this is the IP for host 2, and let's say they have assigned any port number 1400. Hmm? And for example, let us also assume that this host 2 having this IP number is also assigned the 1400. So how it is going to be taken care? So when this entry has been made here, and when this request has been sent in the NAT table, so it will discard the request, because this number has already been given to other host machine. So this port number is should be different. So it will discard this request and will ask to the to this host to regenerate a new port number. So then when the request is discarded, the machine will again give the other port number, which is not the same as 1400. So let's say the other time it's get 1401 or 1701, and then it is going to accept. So in this case, so in this way, you can see that all the entries must be unique and can be easily resolved, and there is no clash happening. This is how the NAT table is going to resolve all the clashes and can easily manage private to public and public to private, and the communication can be done very smoothly. So this is all for the NAT discussion. I think you have understood how the NAT tables are working. See you in the next video. Take care.